Namaste. Welcome to our YouTube channel. So today we are going to discuss question number 6 from PSB 2023, where the question says that this is the PDF we are given with, and we have two random variables x1 and x2 independently drawn from this particular PDF. And theta is greater than 0. We need to find out the maximum likelihood estimator of theta for all the three cases. So let us start with the basic concepts that we might need for this problem. The first one is the definition of MLE. So if x1 and x2 are given, the definition of MLE is the value of theta for which this particular likelihood function is maximum. Okay. The second one is that if x1 and x2 are independent and identical with the PDF f theta x, then their joint density is nothing but the product of their marginal densities. The third one is that for this particular problem, our PDF can be rewritten in this format, where indicator function denotes that this particular indicator function is 1 when this event 0 less than or equal to x less than or equal to theta, this holds, then this indicator is 1, otherwise 0, same for this. Now you can see that from this two indicator functions, only one can be 0 at a time, or only one can be 1 at a time. Exactly one of those two will be 1. Both cannot be 1 because theta is greater than 0, and we do not consider the case that both are 0, because in that case, x is not in the range itself. If both are 0, then it is lying in this otherwise region, right? Alright. So let us use this particular concepts in our solution. What is the joint distribution of x1 and x2? This is nothing but this. I'm just multiplying the densities that we derived at the previous slide for x1 and x2. And the next step, I'm rewriting the same thing, but I'm putting the minimum value of this 2 as x order 1 and x order 2 denote the maximum of this 2. Okay, since this is a continuous density, we can say that both of the values, they will be same with 0 probability, right? In the third step, I'm just expanding this. I'm multiplying this 2 cross 2 quantities and getting this 4 elements, okay? And in the fourth step, let us now closely look at each of the elements. For the first indicator function, it is indicator of this into indicator of this. Now, this is 1 only when theta is greater than or equal to x order 2, because this is 1 when both of this are true. And both of these are true if theta is greater than x order 1 and x order 2. That is true when theta is greater than the maximum, right? So that is what I'm writing here, that if both of them are true, that is equivalent to the case that theta is greater than or equal to maximum of both the values. Now in the second one we have that x order 1 lies in this region and x order 2 lies in this region. So theta is greater than or equal to x order 1 and theta is greater than or equal to x order 2 by 3. So basically theta is greater than or equal to maximum of x order 1 and x order 2 by 3. And also we have that theta is less than or equal to x order 2 by 2. So this is the whole condition. And you can see that the third condition can never hold, because x order 1 is lying at some upper segment, whereas x order 2 is lying at some lower segment, which cannot hold because x order 1 is the lesser value. Okay. And in the fourth condition, so here, when do we get 1 for both the indicators? When theta is greater than or equal to x order 1 by 3 and theta is greater than or equal to x order 2 by 3. So basically theta is greater than or equal to x order 2 by 3 is that is the maximum of this 2. And similarly theta is less than or equal to x order 1 by 2. So this is the simplified PDF, simplified joint PDF that we get, right? So this is our joint PDF. Now for each of the three cases, we can simply put the value of the minimum and the maximum x. And we can see that for which theta, actually we are getting the maximum of the whole likelihood function, right? So let us move on to that. So this is the likelihood function we have. In the first case, so this is the first case. Here we can have 1 at exactly one of these three indicators. So if theta satisfies this, then the minimum value of theta will be 9. If theta satisfies this, now you can see that this region is something which can never actually hold true, because theta cannot be greater than or equal to 7 and less than or equal to 4.5. So let us leave it. And in the third condition, we have the minimum value of theta is 3. So we can see that 1 by 4 theta square will be maximum for the minimum value of theta. And the minimum of value of theta is 3 if theta is in this region. So we can say that for this particular case, our MLE is nothing but 3. Okay. So that is the case for the first part. What is the second part? In second part also we can see that this region cannot hold, and from this region and this region, when theta is lying in this region, then only the minimum value is 4, and hence that is the MLE for this particular case. Okay. And in the third case we can eliminate both the second and third indicators because they cannot really hold true. The first one, theta greater than or equal to 9 is true, and the minimum value of theta is 9. So that is where we are getting the maximum value of our likelihood. Okay. So theta hat is 9. So that is how we can solve this problem. So we have to remember that the first thing that we are doing is we are simplifying the MLE, we are simplifying the likelihood so that the calculation gets simpler. Okay. So that is how it is solved now. And if you like this video, spend some time with your family today. Hare Krishna.